Good day everyone. So now we'll discuss about the stack operation and block transfer instructions with ARM7 processor. So basically the stack operations as far as ARM is concerned, you have multiple functionalities like as far as the primitive microcontrollers are concerned, you have some restrictions over here. We can have in any way of pushing it or popping the content inside the stack or from outside the stack also. So these are the different instructions that is concerned with the stack operations of ARM7 processor. So you can see, traditionally a stack grows down in memory with the last pushed value at the lowest address, but the ARM it supports ascending stack and as well as the descending one also, where the stack structure grows up through the memory, and the value of the stack pointer can either you can make it like point to the last occupied address, and while it is for going for the before the push, it needs pre-decrementing and points to the next occupied address, that is empty stack, full stack or empty stack. So these two are the different variants. So initially you have this first instruction, so we'll discuss in detail about each and every instruction, so each and every variant. So STMFD is store multiple and full descending. So LDMFD is load multiple full descending. So in this case, STMFD has its stake in the sense like full descending will be taken care by this store, that is push operation. STM represents push into the memory, while LDM is popping from the memory. So here STM, so we'll take this first as an example. So with this case of STM, the way in which the things goes on will be according to this one. So we'll discuss individually with individual instructions. As of now, we'll discuss only this STMFD. So in this case, you have the stack pointer's content represented over here. You can see it is getting decremented. So once it decrements, full descending in the sense, whatever the memory address that you have specified, it will decrement it, then store, and then store, and the stack pointer's content will be pointing towards the content which it has recently pushed into. So this is full descending. So full descending in the sense, first it doesn't store the content of your register into the memory that has been specified in the stack pointer. Once it will decrement. So here it is initially assumed that the memory address is specified in the stack pointer is 0x4000. Sorry, here it is 0x400. So in 400 nothing has been stored, while getting to the next memory address it is saving this R5, R4. So this R5, R4, R3, R1, R and R0 are the registers. So here R0, R1, R3 to R5 has been specified. So this shows how the content of your internal register of the ARM processor is being pushed into the stack. Stack represents the memory. So let us see it in the CAIL itself, how the operation of STMFD and LDMFD happens. So this is the example. So here what I have done is, we need to give the data into the memory, and from the memory we will be taking the data into the internal registers of your ARM processor, and from there again we will be doing the pushing. So what I have done is, so I have manipulated the value of the stack pointer. So MOV, initially I am putting the value of stack pointer as 0x4 7 zeros, and LDMFD SP. So this is the syntax. You can do it in whatever way you want, but syntax represents the way in which you're supposed to write the instruction. LDMFD SP, if I am putting this exclamatory symbol, it means that automatic increment will happen in the stack pointer. So comma within brackets R0 to R2. So this represents 3 registers will be loaded with the content of the memory address that is starting from this 400000. So this 4 7 zeros will be available in the stack pointer, and from the stack pointer it will be decrementing, that is descending, and it will store the values inside this R0 to R2. So and after that what I have done is I am manipulating the value of stack pointer, but usually when you are doing the stack operation, you are supposed to push the content first, and then you go for popping it. Basically stack operation is for saving the content and using it whenever it is necessary, but to make it understandable, I have done in the reverse fashion, so that to understand how the contents are getting saved inside the memory from your register or from memory towards your register. So I have changed the content of the stack pointer to 0x4 0000018, and stmfd sp stack pointer exclamatory comma within brackets R0 to R2. So this is like pushing it back, pushing to the memory. So let us see how the things happens. So translate, build, and rebuild. So I'm getting into so here I'll view the memory window. Okay, so here for the LDMFD, so as I've already mentioned, STMFD is full descending. So when STMFD is doing the operation in full descending, when the content has to be popped back, while it is doing the LDMFD, it is the popping operation. When pushing operation happens in a descending order, the popping should happen in the ascending order. So obviously the LDMFD will happen in such a way, like it starts from it behaves as empty ascending in the sense, from the beginning, from the first memory address that has been specified, the data will be stored inside your register. So here I'll be mentioning the values 1, 2 and 3. Okay, so now SP is loaded with the memory address, and then you can see LDMFD has happened. So 1, 2 and 3 is now popped into your R0, R1 and R2. Then SP I am the stack pointer content, I am changing it to 400018. So 400018 represents this memory address. So as per the diagram that we have seen, you can see this particular memory address will be skipped, and the next memory address will be stored with the values. So here in this case 400018 has to be skipped, and the values should be saved in 400014 and 400010 and 4000C. So let us see. So you can see 3, this is saved in 400014, and this is 400010, and this is 400000C. So it is now pushed. The data of R0, R1 and R2 has been pushed into the memory. So this is the push operation using the STMFD. So STMFD, it is for pushing, and when it is being pushed, the same way it will be popped back. So to do that popping operation, what happens is, whichever the memory address it is shown in the stack pointer, from there it will be fetching the data. So as far as this is concerned, at last it is coming and staying in 4000C, and now if I am having an instruction of LDMFD from 4000C, it will start to fetch the data into your register. So that will be like popping. So to show that popping and pushing, I have made the program like this. So this is for STMFT and LDMFT. Then the next is STMFA and LDMFA. So STMFA, so that is full ascending. So reverse of whatever has happened over here, full ascending. So in this case you will be specifying a memory address over here, and that memory address will be skipped, and the data, the memory address will be incremented by 1, and it will start to store the content of registers into the stack. So while it is popping back, so as we have seen it for STMFD, LDMFA will happen in such a way that from the memory address that has been specified in the stack pointer, the content will be stored inside the register without decrementing anything. So it will go on. So as I have mentioned, when you are using STMFA, the functioning of LDMFA will behave in such a way like it will be empty descending. So you can see that while this FA has been used for the stack STMFA, your LDMFA, when you are using, it will have the function of empty descending. So opposite of whatever has been mentioned over here, that action will happen as far as LDMFA is concerned. So that is the basically the pushing and popping relation. So now let us check how things happens with the STMFA and LDMFA. So this is STMFA and LDMFA. So as I have done earlier, so because we can't directly push nothing into the memory, so I am assuming that first we are popping some content from the memory and then pushing it into the memory. I am manipulating the stack pointer, but as far as the program is concerned, when you are supposed to use the stack operation, you are not supposed to manipulate the stack pointer. So if you are manipulating the stack pointer, then your content, whatever you are pushing and popping, will be different. So while you are writing your program, when you are using this stack operation, you are supposed to keep the stack pointer, you shouldn't tamper the stack pointer inside the program. So let us see how this STMFA works. So here it is full ascending. So as I have already said, STMFA is full ascending. So LDMFA will behave like LD, that instead of full you'll have to replace it with empty, and instead of ascending it, you'll have to replace it with descending. So obviously 40010, so 40010 I need to take. So I'll make this smaller so that it is easier for me to manipulate. So this is 40010. So here I'll give a value 3, and here 2. This is a 4000C, and this is 40008. So you can see 3, 2, 1 has been stored into R0, R1 and R2. That is LDMFA. So it has fetched the value from 400010 and then 40000C and 4000008. So this is pop operation has happened. Now I am changing the value of stack pointer as 4000020. So now pushing happens to this 400020, that is in ascending. So let me keep it in such a way that so that I can find this 20. So okay, now 20 comes into the visibility. Let us check. Full ascending means 40020 shouldn't get anything, so the data should be stored in 400024 and 28 and 2c. So as I have mentioned, so the data one is stored in 400024, then subsequently 28 and 2c. So this is STMFA. So this is store multiple full ascending, and when it is full ascending in the pushing operation, while it is popping, it will happen in the reverse way. So these two things we have discussed. Now let us go to the next one, that is empty descending. Store multiple empty descending. So in this case, store multiple empty descending. So here in this figure, the values are being presented as it has been specified in this instruction, but whatever the instruction that I am using inside the program, I have used only 3 registers, but here they have used something like 5 registers, R0, R1. This also is possible. This is also one valid instruction. So you can skip in between registers, and you can combine 2 or 3 registers. That also is possible. So here they have skipped R2 register. So R0, R1, R2 they have skipped, R3 to R5 they have mentioned. So R3, R4 and R5 are included. STMED, that is empty descending. So in empty descending, you are having the stack pointer, and the stack pointer content points to the memory. So from that memory itself, it will start to store the data. And after completing the storing operation, it will increment once. The stack pointer will increment once, and it will stay in an empty stack. So this is empty descending. While it is starting to push the data, it starts to push the data in the memory that has been specified in the stack pointer. So let us check that one. STMED. So here empty descending, LDMED. So as I have mentioned earlier, the STMED, so for the store it is empty descending, while it is while it has to happen for LDMED, that is the popping, it has to happen in the reverse of whatever it has been mentioned. So empty will be replaced with full, and descending will be replaced with ascending. So now let us check how things happens. So as I've already mentioned, your LDMED will be behaving like full descending. So full ascending. LDMED will behave like full ascending. So from 400000, so that memory address will be skipped, and 40004 the data will be taken. So I'll type it as 1, this 2 and 3. So you can see 1, 2 and 3 has been fetched. So 4000 has been skipped. So it is behaving like full ascending, because like while STMED is used, your loading has to happen in the reverse way. So that has happened. So pushing has happened, popping has happened. Now I am manipulating the stack pointer as 0x400018. So here it is empty descending. So empty means it will start with 400018. So let me change this one so that I can manipulate it better. Okay, 180 appears over here. So now I'll move it. The stack pointer content has been changed to 40018. Okay, now you can see 40018 is stored with the value of 3, and 40014 is stored with the value of 2, and 40010 is stored with the value of 1. And your stack pointer is pointing to 40000C. So that is this value it is pointing to. So after completion of putting the values into, the pointer points to a value next to it. So 4000018, 4000014, and 4000010. So it is pointing to the value that is empty. So this is empty descending. Then next is STMEA, that is empty ascending. So in this case, STMEA, so your old stack pointer, that is like whatever the memory address that you have mentioned, that is represented as old ASP. So that is 0x400 as far as this figure is concerned, and it starts to store the content over here, and it goes in the ascending fashion. So in the previous case it was descending, now it is ascending for store. So ascending, and after completing the registers, it will store the the stack pointer will come and point to the next memory address where it doesn't save anything. So this is STMEA. So let us check how it happens with the program. So I'll remove this some file, and I'll add the file that is concerned with okay. So empty ascending. So LDMEA. So that is, as I've already mentioned in the previous cases, STMEA is store multiple empty ascending, and LDMEA is obviously load multiple empty ascending. But empty ascending is related only to this store, because while it is popping the content back, it should happen in the reverse way of STMEA. So obviously it will behave as full descending. So E should be replaced with F, and A should be replaced with D. So now let us check how things happens. I said LDMEA, that is descending. So your memory address has been specified as 4000010. So again I'll change this one so it will be easy for me. Okay, 40010. So it is full descending, I said. So this one will be skipped. So I'll put it as 3, 2, 1. So LDMEA. So you can see 1, 2, 3 has been saved. So one time it has been reduced, and this content goes to R2 register, and this one goes to R1, and the number 1 goes to R0 register. So then after that, as I have done earlier, the stack pointer content, I am manipulating it. I am changing the value to 4000018. So let me adjust this again. Okay, now I'll run the STMEA. So you can see empty ascending. So 4000018 the data will be stored, and 1C, and this is 20, right? So uh, your content of this one gets the content of stack pointer goes to 400024. So um, but you can see the data has been pushed into 400018 1c and 20, and the stack pointer comes and stays in the value where nothing has been saved. So when it is popping back, it will come like this. I mean 400024 will be decremented to 400020, and it will popping the content to your register. Then 400 1c, sorry, I said this is 400 20, then 400 1c and 400018 will, it will be popping it back into the register. So this is the operation of LDMEA and STMEA. So these are the different variants of uh, the stack operation. So stack operation, you have more flexibility as far as the ARM is concerned. So you can push it or pop it in whatever way you can, but the pushing function, whatever you're using, you'll have to associate the same the same function with the popping, which means that if I'm putting SDMFD, I can't use LDMFA, so I'll have to use LDMFD only. So SDMFD and LDMFD goes hand in hand. You can't separate that one. If you're doing it in the other way, you may get a wrong result. So that we'll have to keep it in mind. So coming to the block transfer instruction, so LDM and STM, so the same thing we have used in the stack operation also, but when you're using it for block transfer instruction, your LDM and STM has to be associated with how you want to do the block transfer. Either it is increment after, or a decrement after, or increment before, or decrement before. So in this case, individual instructions operates separately. So you can use any registers over there for I mean pointing the memory. It doesn't necessarily have to follow any pattern as such. So so STMIA and LDMIA will behave in independent fashion. So let us check that one. Okay, now the first one that let us see is LDMIA. So LDMIA and STMIA. So load and store increment after. So in this case, in the loading also it will happen as increment after, and storing also it will happen increment after. That is after you have stored the content from, I mean as far as LDMIA is concerned, you will store the content of the register into the memory, memory into the register. LDM represents data transfer between the memory and the register. So when the transfer happens between your memory towards the register, after the register, I mean the transfer has happened between the memory towards the register, the increment will happen. So let us check it. So now I'm getting into the debug mode. So here I have specified LDMIA R12. R12 I am giving a memory address of 400000. So here R12 I am using the exclamatory symbol so that it increments automatically. So R12 I can use any registers over here, so there is no restrictions. And R0 to R2 are the registers wherein I am going to put the content into. So here I have specified increment after. So increment after in the sense I can start giving the value from here itself. So 40000, then 40000 then sorry 40000 40004 and 4008. So these are the values that I have given. Now let me check. So R12 is loaded with the value, and R14 is loaded with 4000C, and R13 is loaded with 40010. So LDMA, let me check. So you can see from here 1, 2 and 3 has been fetched to R0, R1 and R2. So here in STMIA I am using a different register R13, wherein I have given 400010. So I am using STMIA increment after. So from 400010 it will start to put the value. So this is like 4000, this is 4004 and 8. So I have given this R13 as 10. So let me change this one so that I will get 40010 comfortably. Okay, now I am getting 40010. So here 1, 2 and 3 will be loaded. So you can see 1, 2 and 3 has been stored inside the memory address. So this is store operation, and after it has got stored, so the content of your R13 is supposed to be the stack pointer, that is 40001C. So here while using R13 I have used it since I am not using the stack pointer for some other operation, but while you are using it in your program you'll have to be careful while choosing the R13 register. So since I haven't used R13 for any stack operation, I have used it for this operation. But in case if you are using R13 for stack operation, you can't use it like this. You cannot manipulate it according to your wish. So here what I have done is I am checking this R12 content to check whether all the block transfer has happened effectively. So that's the reason I am comparing R12 and R14. So here R12 is being 40000, so it is increment after. So after it has incremented and initially it will save, then increment, save, then increment, save, and it should show 40000C. So your R12 and R14 should be compared. And in case if okay, in case if R12 and R14 are having different values, it means that the content that has been transferred is not correct. So as of now you can see R12 and R14 is having the same value. So if it is not happening, again this storing and retrieving should happen. So that's the reason I have given this compare statement. So that's it. This is the explanation for increment after. That is load multiple increment after and store multiple increment after. In both the cases it is incrementing after it has saved the content, either from memory to the register or from register to the memory. It is doing the operation first and then it is going for incrementing. Obviously after it has completed the storing of the content, it will the memory pointer will be incremented again at the last. So this is increment after. Next is increment before. So I'll remove this. So here increment before, I need to check how the increment before happens. um, so increment before, in the sense, I have mentioned here R12 is 400000. So this will be incremented before it is going for fetching the data. This R12 will be incremented. So I need to give data from here. So that is 40004. Okay, now I am running the program. So R12 and R14 and R13 has been loaded with. So again I am telling you, even R14 also you'll have to be careful in using it, since I am not using any subroutine or anything. I am using it freely, this R13 and R14. But while you're doing your program, you'll have to be careful using this R13 and R14. So now I am fetching the data from the stack. Sorry, it's not a stack, it's the memory. So you call it as a stack when you do it with the stack operation, but both a stack or memory, it is the same. But since we are representing it just like a block of data, I am saying this as a memory. So 1, 2 and 3 has been fetched. Then R13, that is 40010. So it is increment before, so increment and it will save the content. So 40010, it is skipping, and from the next memory address it is starting to save. So this is increment before. And again in this case also I am comparing this R12 and R14. R14 is 400C. So R12 and R14 are equal, which means that the corresponding content of memory and registers are matching. So this is increment before. Next is decrement after. STMDA and LDMDA. Okay, so here it is LDMDA and STMTA. So that is decrement after. So now we'll go for translate, build and rebuild. So it is decrement after. So your R12 is loaded with 4000C. So it will first it will store the value and then it will decrement. So it is the meaning of decrement after. So in 4000C, from there itself the data will be fetched. So here this is 400010. So obviously this will be the C. So here I'll give a value of 3, and this one 2. Okay, so here it is decrement after. So 40000 C, I can load the value. So 3, 2 and 1 I am giving. So I'll run it. So you can see 3, 2 and 1 has been stored into R0, R1 and R2. So it is decrementing and it is getting the value into the registers R0, R1 and R2. Then and R13 is 400020. So here it is again decrement after. So it will save here in 400020 and 40001C and 40018. So as I said, 400020, 1C and 18, the data has been saved. But your R12 and R14, R12 and R14 I am comparing. So it is like both are 40000, so which represents the data has been transfer has been happened, that is regarding the case of LDMDA. So I'm doing the checking only with the LDMDA, not with the STMDA. So here after the storing has happened and the data and the memory pointer comes and points to the memory address where it hasn't saved anything. So STMDA R13, so 400020 I have mentioned, so it will be in 400014. So that is the R13 content. So this is for STMDA, decrement after. So coming to the next instruction, that is STMDB, that is decrement before. So coming to this decrement before, okay, this is decrement before, in which you can see the decrement before, in the sense before you go for putting the data into the memory or fetching the data from the memory, the decrement operation will happen, that is the meaning. So coming to translate, build and rebuild, I'm getting into the memory. So here R12 has been specified with 40000C. So 40000C will be skipped, and here I'll have to start it with this one. This happens to be the 400018. So there I'll put 3, and here I'll put 2 and 1. So R12 is loaded with 400000C and R14 with 400000. So that is for checking, and R13 is loaded with 40000020. Then LDMDB, that is load multiple decrement before. So as I've already said, the content 40000C has been decremented once, and then the fetching of 3 has happened, and then again decrement again, then 2 is fetched into R1 and 1 is fetched into R0. So your value of R12 will be 40000. It will be pointing to the last memory address that has been fetched into the register. So that is decrement before, that is decrement before. Then STMDB, so R13 is loaded with 400020. So 20 will be skipped, and it will start to store the content from here, that is 4000 1C 18 and 14. So you can see 20 has been skipped, so 1C 18 and 14, and your R13 value will be 14, 400014, as I've already said, and then R12 and R14 will be equivalent, 400000. That represents both the while LDMDB has happened, all the content has been fetched into the register. To check that, I have used that comparison. Otherwise, when we are confident that everything will happen perfectly, then there is no necessity for this comparison. But to check whether things are going on correctly, I have used this one. That's it. This is the explanation for your block transfer instruction. Thank you very much.